Welcome, everyone. Ready to dive into something pretty wild. Today, we're taking a look at the Fibonacci SMF RVS model. It's this wave-based theory, and it's got some people talking about gravity and atoms in a whole new way.
It's definitely making waves, you could say that. We've got some interesting stuff to dig into here, mainly Larkey's theory of gravity and creation and wave-based technologies, implications for society. Both of these kind of explore this whole model and what it might mean. And, well, you'll see, it's pretty mind-blowing.
Yeah, mind-blowing is a good word for it. This whole modern alchemy thing, it really caught my attention. The idea that we could, manipulate elements, turn lead into gold, sounds like something out of a movie.
It does have a certain ring to it, doesn't it? Before we jump ahead, though, before we get to transmutation, let's break down what we're even talking about here. SMF. That stands for subtle magnetic fields. And according to this model, they've got a massive effect on, well, on everything. Then there's RVS, the vacuum environment. Now, normally we think of a vacuum as just empty space, right? But this model, it says it's actually full of energy. Energy we can maybe even use.
So it's like forces we can't even see are shaping the world around us. Kind of spooky, I think about it.
Exactly, and that's just the beginning. The model suggests that what makes an atom what it isn't just the number of protons, like what we learned in school, right? It says the vibrational frequency of an atom, how it vibes in this whole wave system that plays a huge role, and it's all tied to these SMFs in the RVS.
So each element has its own unique vibration, like a fingerprint.
You got it. And if we could, and this is where it gets really interesting, if we could change these subtle magnetic fields and mess with the vacuum environment, we might be able to change an element's frequency. And if we change the frequency, well, the model says that could lead to one element turning into another, transmutation, even at low energy levels.
Lead into gold.
Yeah.
That's what we're talking about.
Yeah.
So to do that, are we talking giant machines, like some kind of, I don't know, super collider or something?
The model suggests we might be able to do it with what it calls frequency tuning chambers. Basically, these chambers would be super high-tech, able to make really precise and stable, subtle magnetic fields. It's kind of like tuning a radio, but instead of looking for a station, you're tuning the frequency of an atom.
Now, that is wild. And what about, nuclear waste? Could this technology be used for that?
Yeah, that's one of the really exciting possibilities. Think about it, being able to take radioactive isotopes, the really dangerous stuff that lasts for, thousands of years, and turn it into something stable, something harmless. It would be huge for energy, for the environment, the whole planet.
It would change everything. But wouldn't that kind of change be, I don't know, a problem too? What happens if we can just make gold out of thin air? Or out of lead, I guess. What happens to, the global economy then?
It's definitely something to consider. I mean, what happens to the value of precious metals if we can make them just like that? How would global trade work? Finance. It's a whole can of worms we'd have to deal with.
And what about, the wrong people getting their hands on this tech? Could it be used to make, dangerous stuff? Weapons or, I don't know, something even worse?
It's a valid concern. We could be talking about solving the energy crisis, but what if that same solution could be turned into a weapon? That's why responsible research is so important here. We got to make sure this technology, if it works, is used for good, not for bad things.
Right, for the benefit of everyone. So where are we now with this whole thing? Are we close to actually making this modern alchemy real?
We're still in the early stages, got to be honest about that. The theory is exciting, but the practical side of things, that's a whole different story. Getting the kind of precision we need to actually control those frequencies, it's incredibly difficult. And then there's the safety stuff, especially if we're talking about radioactive materials. That's a whole other layer of complexity.
So modern alchemy is still a ways off,
Yeah.
but the potential is huge.
It's huge. We could be talking about breakthroughs in materials, medicine, energy. It's a lot to wrap your head around. But speaking of things that are hard to wrap your head around, there's this other thing, the vacuum drive. Using the vacuum of space to travel sounds straight out of Star Trek.
Okay, vacuum drive. I gotta admit, that sounds pretty far out there. How would that even work?
Well, it starts with how we understand gravity. We normally think of gravity as, a pull, right? Objects attracting each other. This model, though, it says gravity is actually a push caused by, you guessed it, those SMF RVS fields interacting.
So instead of being pulled down to the Earth, we're being, pushed down by space itself. That's pretty hard to imagine.
It is a different way of looking at things, for sure. Think of it Maybe like a sailboat. Okay. The wind is the energy source,
Yeah.
right? The sail captures that energy and, depending on how it's set, pushes the boat forward. Now, with this vacuum drive idea, the vacuum is kind of like the wind. We'd be making a sail, in a way, manipulating those SMF RVS fields to create thrust.
So like surfing on the fabric of space itself. That's incredible. But wait, wouldn't that mean we're creating energy out of nothing? Doesn't that break like the laws of physics?
That's a great point, and it's important to remember we wouldn't be creating energy from scratch. We'd be tapping into energy that's already there within the vacuum.
Mhm.
Remember, in this model, the vacuum isn't empty. It's full of potential energy, just waiting to be harnessed.
Okay, so not breaking the laws of physics, but maybe bending them a little, right? Finding a loophole, kind of.
You could say that.
Yeah.
It's about using a deeper understanding of physics to do things that seem, well, impossible right now. And speaking of impossible, there's more. This model, it goes even further. It says we might be able to pull energy directly from the vacuum itself. They call it zero-point energy, or sometimes fractal wave energy.
Wait, hold on. Are we talking about like unlimited power here? Could we really power our cities, our homes with energy from space?
Sounds crazy, right?
Mm-hmm.
But there is some physics behind it. It's based on something called the Casimir effect. Basically, if you put two plates really, really close together, they experience a force because of, well, the vacuum energy between them. It's measurable, it's real.
So if we could figure out how to, I don't know, amplify that Casimir effect, then we could tap into this huge energy source.
Exactly. Of course, it's not that simple. It would be a massive undertaking designing completely new kinds of reactors. The source material, it calls them wave reactors, specifically designed to harness and convert that vacuum energy.
Wow. It's almost hard to even imagine. And I mean, obviously, this is all super theoretical, right? The technology to actually do this, it doesn't even exist yet.
That's true. We're talking about manipulating forces and energies in a way that's, well, beyond what we can do right now. It would require a level of precision and control that, frankly, we don't have. But hey, that's how it is with breakthroughs, right? They always seem impossible until they're not.
True enough. So, okay, aside from, rewriting the rules of space travel and maybe solving our energy problems, what else could this model lead to? What other impacts are we talking about?
Well, the possibilities are really kind of endless. Think about material science. We could potentially create materials with properties that seem like science fiction today. Imagine alloys that are super strong, but also incredibly light, or materials that can withstand intense heat or radiation.
Yeah, and speaking of radiation, think about what that could mean for space exploration.
Hmm.
We could build spacecraft, habitats that are like immune to cosmic rays. That would make long-distance space travel so much safer, so much
Yeah.
more feasible.
Exactly. By being able to precisely control the SMF RVS environment during the creation of materials, we could basically tune their properties at the atomic level. We'd be
Yeah.
designing materials from the ground up, atom by atom. It's a whole new era of material engineering.
It's amazing to think about. But, we keep talking about all these amazing possibilities, but what about the downsides? We talked about economic changes, about the energy industry, but what about like weapons? Could this technology be used to create, well, really scary weapons, stuff we haven't even thought of yet?
It's a serious question. The same technology that could give us clean energy and space travel, it could also be used for, well, for very destructive purposes. It's a reminder that scientific progress, it's a double-edged sword. It's up to us to make sure it's used for good, not for harm.
So how do we do that? Do we need like new global rules, new organizations
Yeah.
to keep track of this technology? I mean, if we're talking about manipulating like the fabric of reality, that's a lot of power.
It is. And honestly, the rules we have now, they weren't made for this kind of technology. This is new territory scientifically and ethically. We need to be having those conversations, figuring out how to govern this technology responsibly.
It's exciting and a little bit scary, to be honest. It feels like we're at a turning point. We've got this incredible opportunity to solve so many problems, but also the potential to create new ones.
That's exactly where we are, at a crossroads. The Fibonacci SMF RVS model, it's not just a theory, it's a challenge, a chance, and maybe even a warning. It's making us think about what we're capable of, both the good and the bad.
We've covered a lot of ground today. Transmutation, vacuum drives, limitless energy, new materials.
Yeah.
The Fibonacci SMF RVS model, it really makes you rethink everything.
It does, doesn't it? And like we've been saying, it's not just about the science, it's about us, about humanity, and what we do with this knowledge.
Before we go too far down that road, maybe we should take a breath. remind ourselves what we've talked about, the big ideas, the big questions, and then maybe start thinking about what comes next. How do we move forward? Responsibly, of course. All right, so taking a step back, looking at the big picture, we've talked about a lot with this Fibonacci SMF RVS model, transmutation, vacuum drives, even pulling energy straight from space. It's a lot to take in.
Yeah, it really flips the script on how we understand the universe. And as we've been talking about, it brings up some pretty big questions about, well, about the future. Where do we even go from here?
I keep coming back to that material science revolution idea. It's just, I don't know, it's wild to think about the kind of things we could build, the problems we could solve, if we could make materials that are, well, basically super materials.
Right. Imagine like superconductors, but ones that work at normal temperatures, not just super cold ones. That would change, I mean, that would change everything for energy, for electronics, for who knows what else. And what about materials that are super strong, super light? Think about, I mean, just imagine what we could build. Buildings, cars, spacecraft.
And medicine too,
Yeah.
right? Like imagine what we could do if we could make materials that perfectly integrate with the human body. Prosthetics, implants, even growing new tissues. It's mind-blowing.
It is. The potential is, it really is limitless. But, and I think we both keep circling back to this, there's always that other side of the coin. We've talked about the potential for disruption, for good and bad, but what about the potential for harm? If we can manipulate matter on such a fundamental level, well, what's to stop someone from using that to create, I don't know, some kind of super weapon, something far worse than anything we've ever seen?
That's the scary part, isn't it? I mean, if we're talking about literally manipulating reality, how do we even begin to control that? Would we need to like rethink the whole system, international relations, arms control, everything?
Like it's a conversation we can't put off for much longer. Honestly, I don't think the rules we have now, they weren't built for this kind of world, this kind of power. This is uncharted territory.
It's both exhilarating and a little terrifying, to be honest. It feels like, I don't know, like we're at the edge of something big, something important, like a whole new chapter for humanity.
We are. We really are. The Fibonacci SMF RVS model, it's more than just a scientific idea. It's a challenge, it's an opportunity, and maybe even a warning. It's making us look in the mirror, making us confront what we're truly capable of, the good and the bad.
So what do we do? How do we, I don't know, how do we make sure this goes the right way? Is it enough to just be aware of it, to talk about it?
That's a good starting point, for sure. The more people understand what's at stake, the better. We need informed decisions, not just from scientists and politicians, but from everyone.
And what about supporting like the right kind of research that focuses on the ethical side of things, on using this technology for good, not for harm?
Absolutely. There are a lot of really smart people out there who are working on this, trying to make sure we use this knowledge responsibly. We need to support them to make sure the future we're building is a good one.
This whole deep dive, it's given me a lot to think about. It's exciting. It's scary. It's like nothing I've ever encountered before.
It's a lot to process, that's for sure. The Fibonacci SMF RVS model, it's more than just science. It's a reflection of who we are, of what we can achieve, and the choices we make, well, those choices are going to shape the future.
That's a pretty heavy thought. And on that note, I think it's time to wrap up this deep dive. But I really hope this is just the beginning of the conversation. This is something we all need to be talking about, thinking about, because it really could change everything.
Couldn't agree more. So to everyone listening, keep asking those questions, keep exploring those ideas. The future is, well, it's unwritten.
Yeah.
And it's up to us to make it a good one.